channel AskPrep. In today's series on 11th grade chemistry, we will be studying Chapter 3, Classification of Elements and Periodicity in Properties, in detail. Let's start the video. Starting with genesis of periodic classification, Dobereiner's triads. In 1829, Dobereiner arranged certain elements with similar properties in groups of 3, such that the atomic mass of the middle element was nearly the same as the average atomic masses of the first and third elements. A few triads proposed by him are listed. Limitations of Dobereiner's triads. Dobereiner's triads were useful in grouping some elements with similar characteristics, but he could not arrange all the known elements into triads. Next is Newland's law of octaves. John Newland proposed the law of octaves, which states that when elements are arranged in order of increasing atomic masses, every eighth element has properties similar to the first. Newland called it the law of octaves because the relationship is analogous to the octaves in music. Limitations of Newland's law of octaves. This classification worked only up to calcium. Beyond that, every eighth element did not necessarily have properties similar to the element lying above it in the same group. The discovery of noble gases later disturbed the arrangement of the elements. Next is Mendeleev's periodic law. The physical and chemical properties of the elements are periodic functions of their atomic masses. Mendeleev arranged the elements known at his time in order of increasing atomic masses, which led to the creation of the periodic table. Elements with similar characteristics were placed in vertical columns called groups, and horizontal rows were known as periods. Description of Mendeleev's periodic table elements are arranged in vertical rows called groups and horizontal rows known as periods. There are 9 groups indicated by Roman numerals 1 to 8 and 0. Group 8 consists of 9 elements arranged in 3 triads. The 0 group contains inert gases or noble gases, which have 0 valency. There are 7 periods numbered from 1 to 7. Importance of Mendeleev's periodic table. The table provided a systematic approach to studying elements. Knowing the properties of one element in a group allowed for the prediction of properties of others. It greatly facilitated the discovery of new elements. Mendeleev corrected the atomic masses of certain elements based on their expected positions and properties. Defects in Mendeleev's periodic table. Hydrogen was placed in group 1A with alkali metals but also resembled the halogens of group 7A, making its placement controversial. Although elements were arranged by atomic mass, some elements with higher atomic masses precede those with lower atomic masses. Isotopes of an element which have different atomic masses but the same atomic number would need different positions in the table if it were based solely on atomic mass. Elements in the same group did not always exhibit similar properties, and some elements with similar properties were placed in different groups. Lanthanoids and actinoids were placed in separate rows at the bottom of the periodic table without a clear rationale. There was no proper explanation for why elements in the same group show similar properties. Next is modern periodic law. The physical and chemical properties of the elements are periodic functions of their atomic numbers. Present form of the periodic table, modern periodic table. The modern periodic table is based on the modern periodic law. Elements are arranged in order of increasing atomic numbers. Nomenclature of elements with atomic numbers greater than 100. You can go through this image. Next is structural features of the periodic table. First is group. The modern periodic table consists of 18 groups, each of which is an independent group. Characteristics of groups. All elements in a group have the same general electronic configuration. Elements in a group are separated by definite gaps in atomic numbers 2, 8, 18, 32. Atomic size increases down the group due to the addition of electron shells. Physical properties such as melting point, boiling point, density, and solubility follow a systematic pattern. Elements in each group generally exhibit similar chemical properties. Periods. Horizontal rows in the periodic table are known as periods. There are 7 periods in the long form of the periodic table. Characteristics of periods. In all elements present in a period, the electrons are filled in the same valence shell. Atomic sizes generally decrease from left to right. S-block elements, general electronic configuration, NSON or NSTWO. Characteristics of S-block elements. All the elements are soft metals. They have low melting and boiling points. They are highly reactive. Most of them impart colors to the flame. They generally form ionic compounds. They are good conductors of heat and electricity. P-block elements, general electronic configuration, Ns2np1 to Ns2np6. Characteristics of P-block elements. The compounds of these elements are mostly covalent in nature. They show variable oxidation states. Moving from left to right in a period, the non-metallic character of the elements increases. The reactivity of elements in a group generally decreases downwards. At the end of each period is a noble gas element with a closed valence shell, Ns2np6 configuration. Metallic character increases as we go down the group. D block elements, general electronic configuration, N1D1 to N1DTNN0 to NS2. The D block elements are known as transition elements because they have incompletely filled d orbitals in their ground state or in any of their oxidation states. Characteristics of D block elements. They are all metals with high melting and boiling points. The compounds of the elements are generally paramagnetic in nature. They mostly form colored ions and exhibit variable valence oxidation states. They are often used as catalysts. F block elements, general electronic configuration, N2F12, N2F14, N1D02, N1DN2. They are known as inner transition elements because in the transition elements of the D block, the electrons are filled in the N1D, N1D subshell, while in the inner transition elements of the F block, the filling of electrons takes place in the N2F subshell, which is one inner subshell. Characteristics of F block elements. The two rows of elements at the bottom of the periodic table are called the lanthanoids. Cerium, Z-Chas 58 to lutetium, Z-Char 71, and actinoids, thorium, Z-Ve90 to lawrencium, Z-Ve103. These two series of elements are called inner transition elements, F block elements. They are all metals. Within each series, the properties of the elements are quite similar. Most of the elements in the actinoid series are radioactive in nature. Next is metals. Characteristics. Metals comprise more than 78% of all known elements and appear on the left side of the periodic table. Metals are usually solids at room temperature. Metals generally have high melting and boiling points. They are good conductors of heat and electricity. They are malleable and ductile. Non-metals, characteristics. Non-metals are located at the top right-hand side of the periodic table. Non-metals are usually solids or gases at low temperatures with low melting and boiling points. They are poor conductors of heat and electricity. The non-metallic character increases as one goes from left to right across the periodic table. Most non-metallic solids are brittle and are neither malleable nor ductile. Metalloids, the elements silicon, germanium, arsenic, antimony, and tellurium, exhibit characteristics of both metals and nonmetals. These elements are also called semi-metals. Noble gases, these are the elements present in group 18. Each period ends with a noble gas element. All noble gases are gaseous and have filled orbitals, resulting in very little tendency to take part in chemical combinations. They are also called inert gases. Representative elements, the elements of group 1, alkali metals, group 2, alkaline earth metals, and groups 13 to 17 constitute the representative elements. They are elements of the S block and P block. Transition elements. The transition elements include all the D block elements and are present in the center of the periodic table between the S and P block elements. Next is inner transition elements. Lanthanoids, the 14 elements after lanthanum, and actinides, the 14 elements after actinium, are called inner transition elements. They are also called F block elements. The elements after uranium are also called transuranic elements. Ionic radius, the ionic radii can be estimated by measuring the distances between cations and anions in ionic crystals. In general, the ionic radii of elements exhibit the same trend as the atomic radii. Cation. The removal of an electron from an atom results in the formation of a cation. The radius of a cation is always smaller than that of the atom. Anion. The gain of an electron leads to an anion. The radius of an anion is always larger than that of the atom. Electronegativity. Electronegativity is a qualitative measure of the ability of an atom in a chemical compound to attract shared electrons to itself. Unlike ionization enthalpy and electron gain enthalpy, it is not a directly measurable quantity. However, several numerical scales of electronegativity, such as the Pauling scale, Mulliken-Jaffe scale, and Allred-Rochow scale, have been developed. The electronegativity of any given element varies depending on the element to which it is bound. Across a period, electronegativity generally increases from left to right. In a group, electronegativity decreases down a group. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.